Hello everyone, welcome to Daksh Chemistry. Today we will going to discuss previous year questions asked in CSIR NET GATE based on proton NMR spectroscopy. Let's start. Our first question is, a compound shows a proton NMR peak at 240 Hz downfield from the TMS peak in a spectrometer operating at 60 MHz. What are the value of delta value in ppm relative to TMS? Given options are 4 ppm, 6 ppm, 8 ppm and 5 ppm. We will calculate the delta value by this formula. This mu is the frequency of signal of compound minus frequency of the reference compound into 10 to power 6 by spectrometer frequency. So it is given that the difference between these two frequencies are 240 Hz and spectrometer frequency 60 MHz. So calculating the delta value by this formula. Next question, the H1-NMR frequency at 1 Tesla is 42.4 MHz. If the gyromagnetic ratio of H1 and C13 spectrum are 27 into 10 to power 7 per Tesla per second and 6.75 into 10 to power 7 per Tesla per second, what will be the C13 frequency at 1 Tesla? Given options are 10.6 MHz, 42.6 MHz, 169.6 MHz and 21.3 MHz. We have these two formulas by which we will calculate the gyromagnetic ratio, and from these two formulas we conclude that our gyromagnetic ratio directly related to frequency. Gyromagnetic ratio directly related to frequency. So gyromagnetic ratio for H atom divided by gyromagnetic ratio for carbon atom is equals to frequency for hydrogen atom and frequency divided by frequency for carbon atom. So these value put into the formula. There we will calculate the frequency for carbon atom and we get 10.6 MHz frequency. So correct option is option 1. The third question is, the G factor of H1 and C13 are 5.6 and 1.4 respectively for the same value of the magnetic field strength. If the H1 resonate at 600 MHz, the C13 would resonate at. Given options are 2400 MHz, 150 MHz, 600 MHz and 38 MHz. By this formula, we calculate our frequency. So from this formula directly relates frequency with G factor. Frequency is directly proportional to G factor. So frequency for H atom divided by frequency of carbon atom equals to G factor for H atom divided by G factor for carbon atom. So these values are put in the formula and calculate the frequency at which C13 would resonate. We get 150 MHz. So correct option is second option, 150 MHz. Next question. For a certain magnetic field strength, a free proton spin transition occur at 700 MHz, keeping the magnetic field strength constant. The N14 nucleus will resonate at if the G factor for proton is 5.6 and G factor for nitrogen 14 is 0.4. Given options are 700 MHz, 200 MHz, 400 MHz and 50 MHz. So as we saw in the last question, G factor directly relate with the frequency. So G factor for proton divided by G factor of N14 equals to frequency of proton divided by frequency of N14, and these given values are put in the formula and we will calculate our frequency. So answer we will get 50 MHz. So correct option is 4. Next question is, H1-NMR spectrum of an organic compound recorded on a 500 MHz spectrometer show a quartet with line position at 1759, 1753, 1747 and 1741 Hz. Chemical shift, delta value and coupling constant of a quartet are given. Options are 3.5 ppm 6 Hz, 3.6 ppm 6 Hz, 3.5 ppm 12 Hz, 3.6 ppm 12 Hz. Firstly, we will calculate the J value, coupling constant. So what is the coupling constant? Distance between the peak in a given multiplet is a measure of splitting factor known as coupling constant. Distance between these two peaks. This is the coupling constant, J value. Okay. We have given these four values for the peaks in the multiplet. Calculate the difference between them. We get 6. So, coupling constant is 6. These two options C and D are eliminated from here. We will go only for first and second for calculating the chemical shift. Okay. Chemical shift is equals to frequency of signal minus frequency of reference into 10 to power 6 divided by spectrometer frequency. So, we have given spectrometer frequency 500 MHz and we will calculate the average value of these four multiple peaks for this value. So, 1750 divided by 500 MHz, we get 3.5 ppm delta value. So correct option is option A. Next question, in a 200 MHz NMR spectrometer, a molecule shows two doublets separated by 2 ppm. The observed coupling constant is 10 Hz and the separation between these two signals and coupling constant in a 600 MHz spectrometer will be respectively first option 600 Hz and 30 Hz, second 1200 Hz and 30 Hz, 600 Hz and 10 Hz, last one 1200 Hz and 10 Hz. This is a very simple question because we have already given the coupling constant 10 Hz. So our correct option is either third one or fourth one. These two options are already eliminated. We calculate only separation between two signals. So how it calculate? As delta value is given, x is the separation between these two signals divided by spectrometer frequency, which is 600 MHz into 10 to power 6. So we calculate value for x, we get 1200 Hz. So separation between two signals and coupling constant is 600 Hz, 1200 Hz and 10 Hz. Correct option is answer 4. Next question is, in an NMR spectrometer containing 2.5 Tesla magnetic field, Larmor precessional frequency of H1 is 100 MHz. The radio frequency used in this spectrometer as an associated magnetic field of 2.5 into 10 to power minus 4 Tesla. The duration of 90-degree pulse in this instrument is 25 into 10 to power minus 6 second, 25 into 10 to power minus 5 second, 50 into 10 to power minus 6 second, 50 into 10 to power minus 5 second. It is somewhat typical question. In associated magnetic field, magnetization vector M at thermal equilibrium show RF excitation when we give radio frequency pulse at 90 degree. Okay. In RF field will be calculated by this formula. 1/4 multiplied by 90 degree pulse duration. And this radio frequency is equals to gyromagnetic ratio for hydrogen atom. We have not given in the question gyromagnetic ratio for the hydrogen atom. We have to learn it. Okay. So now calculate RF field for this. We get 23.5 into 10 to power minus 6 second. 25 into 10 to power minus 6 second. So correct option is option A. Last question. What magnetic field strength is required for proton magnetic resonance at 220 megahertz if G value for proton is 5.585 and given options are 5.17 Tesla, 4.57 Tesla, 7.25 Tesla and 5.95 Tesla. So frequency at which proton resonate equals to mu n, magnetic moment for proton atom, G factor and magnetic field. Del mu is given 220 megahertz. We can change it into hertz. 220 into 10 to power minus second hertz or second per second. So magnetic field is equals to del mu divided by mu n into G. Put the values for these three expressions. We get 5.1715 Tesla. So the correct option is option A.